This is CPM Precalculus Chapter 3, number 106. So if you look at your calculator, just below the log key, there is a key labeled ln. So if you look at it, see, here's your calculator. Right next to the 7, right, is our log key here. And below it is the key ln. Okay? We're going to go ahead and discover what this is today in problem 106. So first we're going to ask, do the three log laws work with ln? For example, is it true that ln of 3 plus ln of 2 is equal to ln of 3 times 2, right? So first you might want to check all three log laws and just have several examples before we decide yes or no. And what are the log laws? We have the log of a product, the log of a quotient, and the power law, right? So let me write them right here. The log of a product, the law of a quotient, and the power law. Right? And those are in the math notes under the laws of logarithms. Log of 3 ln of 3 plus ln of 2, well, that's going to fall under the log of a product, right here. So let's go ahead and write that one here. Ln of 3 plus ln of 2, is that equal to ln of 3 times 2? Well, let's go ahead and check that. So let's bring out our calculator, turn it on, and bring out your calculator too and check it as well. So go ahead and type in ln of 3. Oh, you want to type in ln, right? Ln of 3, close the parentheses, plus ln of 2. All right? When you get that, put enter, and it's going to give you 469, no 1. All right, so then let's go ahead and check what is ln of 3 times 2 inside of the input to ln. Put enter, and that's going to give us the same thing, right? So yes, this is the same. So I'm going to go ahead and put a check mark because we went and tested that, and it is true. Okay, the law of a quotient, remember, this is where we do log of something over something. So let's try 3 over 2, right? And we want to test, well, is that equal to, sorry, it's not log here, we're testing ln. So let's go ahead and say ln of 3 over 2. And we want to test, is that equal to ln of the numerator here minus ln of the denominator. So let's go ahead and test that. I'm going to clear my calculator. I'm going to put ln of 3 divided by 2, and I'm going to put equals. That gives me 0.40546, so on. Okay, and then I'm going to test and go ahead and enter ln of 3, close the parentheses, minus ln of 2, and check that. And these are also equivalent. Because right now when I'm writing this, I don't know if they're equivalent or not. So I can even put a question mark above these, and I'm verifying it, so I'm going to put a check when I'm done. The power law tells us log of x to the n, so I'm going to, instead of log, I'm going to use ln. Instead of x, I'm going to say 2 to the power of 3, and is that equal to question mark n times log x? So n was the power, so it's 3 times ln of 2. Are these equal? So now I'm going to go ahead and test that. Let's clear my calculator. ln, and then inside the ln I'm going to put 2 to the 3 power. That's going to be 2.079 ... And then I'm going to test 3 times ln of 2. And that gives me the same output. So yes, those are equal as well. So what we should do is go ahead and test a few different values before we go ahead and say, yeah, we see that the three laws check out. So let's try ln of, 17 minus ln of 5. I'm just doing some random numbers, and let's see, question mark, is that equal to ln of 17 times 5? So then I test this, ln of 17, let me clear first, ln of 17 minus, sorry, this is plus the law of a product, so let me go ahead and change that to plus ln of 5 and test that, and then test out ln of 17 times 5. Okay, and yes, those are equal as well. So you might want to try a couple of these using the law of product, using ln, just to go ahead and see, do the 3 log laws work. Okay, so I'm going to let you go ahead and finish a few more examples for all 3 laws. So go ahead and do that. Have at least 2 examples for each. Alright, let's go on to part B. Part B says, since ln appears to satisfy all 3 log laws, so it does, when you are done, you're going to see that yes, these all are satisfied. It appears to be a log function, right? ln is a log function. And ln of x is written usually as lowercase letters ln of x with parentheses or without. Okay, so either one is going to be represented in different formulas, and you could use either one as well. When speaking, you say the 2 letters separately, ln. So it's not like ln or anything like that. It's ln of x or ln x. Okay. The letter L stands for logarithm, right? Just like log. And the letter N stands for natural. Okay. So it's the natural log. ln of x is a natural logarithm of x. For logs of base 10, log of 10 is equal to 1, right? There's an implicit invisible base 10 there. For logs base b, explain why log base b of b is equal to 1. So log base b of b is equal to 1. Well, why is this true? Let's go ahead and rewrite this into its equivalent exponential form. That's going to be whatever is here, b equals b to the power of 1, right? And are those equivalent? Yes, they are. So b is equal to the power of 1 is why this is true, because this is rewritten like this, and we know b is equal to b to the power of 1, and that's true, and so that is why this is true. So this is the explanation by rewriting it in exponential form. Alright, let's go on to part C. By experimenting with different inputs, use the result in part B to find the base of the natural logarithm function to the nearest 0.001. Alright, so we know ln, you can write it with a cursive L. I usually see it with cursive L's more often because ln sometimes is mistaken as 1n, right? Ln of x is equal to a log with some base of x. Okay, so this is what we're figuring out today. It's just some base. We don't know what b is, right? We want to find what b is equal to the nearest 0.001. So b is equal to something. So given that this is true, right, let's go ahead and test out some different values. So you could pick pretty much your favorite number, right, that is positive, because the input to a log has to be positive. So I'm going to try, for example, ln of 5. Okay, so ln of 5, so I'm going to write that example. Ln of 5 equals to, and I'm not going to round here, I'm going to write this whole string of numbers, 1.609437912. Okay, and how would we write this in exponential form? Well, remember, ln is some log base b, right? We don't know the base yet. We're trying to figure that out. And so we could rewrite this as 1.609437912. We could write it like this. Since we know ln is a log, we just can write it like this. And this we can go ahead and rewrite in exponential form, right? It has an equivalent exponential form, which is b, right? 5 equals, I'll write 5 equals, what's here, equals b to the power of 1.6. b to the power of 1.609437912, right? So we have b to this power is equal to 5. So how do we go ahead and solve for b given this information, right? Well, what you're going to want to do is you're going to want to cancel this exponent somehow. So what you can do is multiply both sides, or take both sides to the reciprocal of that number. 1 over 1.609437912, and take 5 to that same power. 1 over 1.609437912, right? Then these cancel out on the right side. So you're left with b on the right is equal to 5 to the power of 1 over 1.609437912. It might seem silly not to round this, but you want to get very good accuracy, so you don't want to round. Okay, so let's go ahead and put this in our calculator. 5 to the power of 1 divided by 1.609437912. And what do we get? We get b is equal to 2.718281829, right? Okay, so this is one value for b. So this is telling us that ln of x is equal to log base 2 all of this, but I'm going to round it to 0.001 decimal places, so I'm going to truncate this off, right, is equal to log of base 2.718 with the input of x. These are equivalent, okay? But is this accurate? You should try another number as well. Don't just use 5, use another number. So try ln of another number other than 5 and do another test, and go ahead and see, is this the number you get, or are you going to get a slightly different number? Okay, so that's going to end for us CPM Precalculus Chapter 3, number 106.